Hi, this is János, it's Real World Audio, and it's time to celebrate. If he was alive, Stu, my mentor, it would be his birthday today. So that's why I thought let's just give him a little birthday surprise. Uh, when he was alive, he was never into celebrating his birthdays, or at least like getting gifts for birthday, because he said that it was my mom doing all the hard work, so why should it be any special? However, uh, what Stu thought of special were when we did experiments, when we did something and we shared it with him. That was what made him happiest. So that's what I'm going to do today. I'm looking at one of my older videos. This is the video that was from 2 years ago, and I just received a comment there, and this is the comment I'm talking about. T. Momedrano shared it just now, and this is an experiment that he did, and I hope, Stu, you are watching. So basically this video was about changing your capacitor input supply to a choke input supply, and this is what he did. He took out the input capacitor and doubled the capacitance after the choke. He had a 5U4 rectifier and an EL84 single-ended triode. So basically he took out the first cap, and then there was a choke, and then he doubled the second capacitor. What was the result? There was more hum, but only slightly audible, even with sensitive speakers. However, the sound became more detailed and stereo separated. And so I think this is the thing that all of us should be doing. Experiment and try it out for yourself, and find things out. And this is how you will learn, how you will find out what is it what you want, what is better for you, and this gives you so much more power than just selling an app and buying another one, and because then you are just changing so many parameters that you have really no clue what made the change between the two sounds, and you will be never happy, because with every change of an amp you are changing so many factors, while at one point you should be changing only one, and step by step by step by step by step by step you will get there. But if you keep on changing amps, then it road is like that, and it's taking you all over the place, and there's no destination where you are going to, no clear destination. You are just erratically flapping like a fish on the dry ground on the shore. So basically that's one thing that you can do, is experiment for yourself, and this is like really fantastic sharing, because that's not something usual that you see people do with their amplifiers to convert it from capacitor input to choke input. However, maybe let's just scroll up. So this was part of the video. I just paused it at the beginning. So this is what we see here. We see the rectifier. In this case, that's a 6BY5. This was in my video, and this is just one, because these are half-wave rectifiers, so there's two of them. There's one below that we don't see here, and the input of the two, so their cathodes are connected together, going through a resistor into the first capacitor, and then here there's a choke, and then there's a second capacitor. So what he did here, that he took out in his, it was a different amplifier, but it was this part of the schematics we are talking about. So when you change your amplifier from capacitor input, you remove this capacitor here, and he doubled up the capacitor here. So here we would just remove, like disconnect this end of the capacitor from this end of the choke and connect it to the other end. That would be the equivalent process in this case. And so can you do it in every case? Or is there a special consideration that you need to know when you are doing this? Yes, there is one very specific consideration, and it's not just the hum level, because when we disconnect a capacitor here and just double up the capacitance there, it will, when we have the choke input supply, it won't have as big ripple filtering as having a capacitor here, so we will have louder hum. But it's up to your amp and your case whether that's going to be something that bothers you or not. However, there's one critical thing that is really a critical thing, is that the inductance of the inductor must meet the minimum critical inductance criteria. What is that? So basically you take the volts of your supply. So from here, what is the voltage that the supply is feeding your amplifier? So let's say it's 400 volts, let's say 400 watts DC. So you take 400. And what is the current that your amplifier draws? Let's say it's 100 milliamps. Then you divide 400 by 100. That equals 4. So the number that you get by dividing your volts with your milliamps, that gives you the minimum inductance, the critical inductance for this input choke that you need. So that's the value. So in this case, 400 divided by 100 equals 4. So here we need an inductor with a 4 Henry or greater inductance. So anything like 4 Henry, 6 Henry, 10 Henry, 20, 30, whatever, will be safe in that position. So what happens when your inductor does not meet critical inductance? So that's my funny story that I'm going to share with you. When my mentor Stu was alive, I shared it with him. He was laughing, but it's fun. You guys, I think some of you will laugh as well, but it's something quite interesting, because even though like searching for decades online for what happens when you don't meet critical inductance, I haven't seen any posts about that. And it's just kind of a legend, and everyone just took it for granted that, you know, you just must meet critical inductance and build an amp like that. But what if you don't meet it? What happens there? Will it hum or what? What's going to happen? So I tried it out. And I tried it out in my 807 single-ended amplifier. It's a tetrode but run in triode mode. I would say, yeah, beam tetrode, which is another way of saying pentode. And so anyway, I don't want to go into that discussion what it is. So basically it is a pentode running triode mode. And the input, I mean the B plus voltage for it was 725 volts. And the two channels were drawing 52 milliamps total. So when you divide 725 by 52, that equals almost 14. Let me cheat. It's 13.94. So the minimal inductance, the critical inductance there is 14 Henry. So what I did there in my supply, let's imagine this is my supply. I had a capacitor here, and then an inductor, and then I had another capacitor. Now this capacitor here was a 40 microfarad capacitor, and then I had a second inductor and a 200 microfarad capacitor. And here normally I had another capacitor, but I took it out. And my inductor here, it is a vintage inductor, and I did not know its exact inductance. Based on its size and the DCR, it was about 6 henries. So now you get this is way below critical inductance. So what's going to happen? And so this is like 2.5 times less than critical inductance. So what I tried out is that I put it on, turned the amp on, of course slowly heated it up with the variac, really nicely turned on, and as I expected, I get the exact voltage that you get with a finely tuned choke input supply. So that was a surprise for me, because I didn't know if it doesn't meet critical inductance, what's going to happen? What is the voltage I'm getting? And I got the exact same voltage with that as if I had an inductor there that met the minimal inductance, so like 14 henries or 20 henries. So what was this voltage? It was 465 watts, so not even 500 watts. So that's how much the voltage dropped. And you can calculate this value, that basically when you have a full capacitor input supply, you will get a 1.4 times higher voltage. And if you have a choke input supply, then you have a 90% voltage compared to what is coming out from here, from your rectifier. And basically, like if you divide 725 by 1.4 and multiply it by 0.9, you get 465 volts, and exactly by the volts I was getting that value. I was, yay, perfect. And then I was listening to it. How does it sound compared to the 725 watts? And yep, there's one thing, as you expected, there's like a major drop in voltage, and that really translated to a much less dynamic sound. So but also it was more relaxed. It was a very relaxed sound, and very spacious, uh, like all the kind of like the static charge in the air, it was gone. It was very beautiful, but I felt that it lost speed. It wasn't as speedy. And then I was listening to it for half an hour, and of course what I did is I had a voltmeter, so I put my voltmeter on the B plus, and that was what saved me. That was probably it saved the amplifier and maybe my life as well. We shall see as we go. So after an hour, I looked at the voltmeter, and the B plus read, I was just shocked because it read 510 volts. I said, what? How is this happening? Voltage rising? What's going on? But yeah, voltage was rising, and it was sounding better and better. I said it sounded noticeably better than with 465 watts. Wow, this is really nice. And then what? Then after half an hour, it started to sound worse. What's going on? And I noticed that it's now like 440 watts. And as it sounded, as the voltage climbed higher, and oh, I'm sorry, I think I ran ahead of myself. So even in the 500s, the sound was getting better and better, and it sounded more punchier, more energetic, more alive, more fantastic. And I was like enjoying it for about an hour and a half, like better and better. Yay, this is fantastic. But I wasn't understanding what's going on. Why is the voltage slowly increasing? And then after that time, when it climbed over 600 volts, that's when the sound quality started deteriorating. and it sounded really bad, anemic, and lifeless, and dimensionless, and all the time it sounded pretty bad for the next half an hour or so, as it was climbing up, and all the time when I was watching, every 10-15 minutes later, a couple volts higher the B plus was. That sounded like Yoda. Anyway, when it hit about 670 volts, then it started really good again, like really, really good. And it was climbing higher and higher. In the 700 volt region, it sounded awesome. But I was scratching my head that I'm getting choke input, but it has as high voltage as if it had capacitor input supply. How is this working out? But I was like, well, fine, you know, amps look stable, voltage slowly rising, whatever. And I was listening to it, enjoying it, and the sound started becoming like noticeably better minute by the minute. And I was also measuring the current running through the power tubes, and I fixed that 26 milliamp per tube. They were not running away really as the voltage was rising throughout from the 465 volts up 26 milliamps on the dot. So tubes were running fine and within dissipation limits, so there was no danger of stressing out the power tubes. So I was fine with it. But then I was reading and I saw 770 volts. What on earth is going on? This voltage now is quite a bit higher than what would be possible even with a full capacitor input supply. And but okay, let's run the experiment more. And then after the voltage went beyond 800 volts, the sound changed dramatically as it hit 800 volts. Like and in the 700 volts range, there's like tremendous dynamics in the sound and power and clarity. It just phenomenal. But when it hit 800, then there was a tremendous relaxedness that suddenly started. It's like the tubes were not stressed anymore. Like all the stress has gone. Just an infinite serenity. It was like something totally beyond what I expected. So my amplifier had the really basic cheap Hammond 125 ESE output transformers, but as the input voltage, the B plus, rose above 800 volts, it suddenly sounded as if I changed them for a Tamura or Tango or Hashimoto output transformers. Like that radical difference. And just reflecting back on this whole thing, the process that I shared with you shows what is the difference when you pick different load lines for your amplifier. You remember that when Susumu Sakuma, he was talking about load lines and how to pick the most optimal load line for your power tubes. That's the difference what the load line makes on the sound quality. And now I got to experience what are the differences in the load line, starting from 465 volts B plus up to, actually I ended the experiment at 825 volts. So that's when I said, okay, I had enough. I can't take this anymore. By the time I was already sweating, you know, like dope. Anything beyond 700 volts was really creepy for me. Even now I don't want to touch high voltages like that. Those are the voltages where when you get zapped, it's not just an ouch moment, that's the moment that your spouse calls the funeral parlor. So and I was not ready for such fun. I'm still not ready. So anyway, I turned it off at that point. But I got to experience all the load lines from 465 volts through 825 volts. And one thing was that I learned from it is that the 465 to 580 volts range, it's a 2 thumbs up for a 10 kilo ohm load for an 8072 tube running triode mode at 26 milliamps current per tube, and also like 550 to 700 volts with the same load is also same current, 2 thumbs up, and above 800 volts, so like 800 to 820, that's the heaven. And when you look at the textbook values, they don't tell anything like that to you. So what I noticed is I've been experimenting with this tube a lot. I tried literally, I think at least 50 or different loading combination for this transformer, and not a single time the most optimal sound was gained by using the textbook values. So when I use the textbook values and use that exact load that the STC manual recommended, that was not the best. I had to go like totally different loads, and that's when I found it. And just reflecting back on this fun experiment, this is what happens when you don't meet critical inductance. So what was happening in this case is that the choke, the inductor, was storing up voltage, and it was building up higher and higher voltage as the time was passing. So that's why it was supplying higher and higher voltage, and higher voltage than the rectifier put out. So that's why I was getting like 800 volts plus from a power supply that even with a full cap input supply is not capable of putting out more than 725 volts. So that's the message to you that I can share. And also what was important in this case, that I did this experiment by having the voltmeter on at all time on the high voltage. And that's my lesson to you all, that if you want to do an experiment of changing your amplifier from choke input to, from capacitor input to choke input, have your meter on it for a couple hours after you do this change to make sure that your input voltage is not running away. Because if it does, after a point, it will reach a point when it's higher than the rated voltage of the capacitors go after that, or higher than the rated volt, not just the voltage, but the rated power dissipation that your tubes can handle, and then it will blow or melt or explode or zap you. So problems can happen. In my case, why I was letting it run to 800 volts or more, it was because all of the capacitors that I used in my amplifier were 1.2 kilovolt rated. So I could have run this experiment quite a bit, but looking back at the STC catalog, the tube data sheets, the curves were running to 850 volts or 900 volts, and where the tube datasheet curves end up to that point, you are okay to experiment. But I was like, okay, cutting it. I don't want to push it to the furthest limit of the tube datasheet curves. Already an 825 volt B plus it's really on the hot side, but as I was running it at a conservative 26 milliamps, I was still not pushing it more than 100% plate dissipation. I think maybe at the end I was at 105% plate dissipation. It's still safe. Plus I had cooling, air cooling, forced cooling on the tubes, so I could have easily pushed them to 130% or even higher, but I don't wanna force my tubes. So anyway, this is my birthday story, and I hope that was a nice celebratory experience for all of you. Thank you for tuning in. Have a great day. Please like if you like this video and share with your friends. And if you want to support me, you can buy me an electronic coffee. There's a link. And if you don't know what that means, it's an electronic system where you can click on the link and you can send me a message there, and you can donate to the channel $2 or more, and that will go into the into me sustaining this channel and helping you out, and just providing a tiny bit of a little bit of fund for me, that to like get a new microphone if the old one craps out, or get a new camera, so yeah, that you can get better experience. And sooner or later I have to get a new computer, because my computer is well, it's kind of getting outdated for this purpose. So if you do that, I really welcome it, and if you have already done it, there's just some of you who are just super duper generous. I'm really, really touched, and Nelly is telling you that stop doing it. You gave János too much already. You guys are just too nice. So thank you. Have an awesome day. Bye bye.